that's not short for that.
There's a balance adjustments, but no one really had any weapons.
But yeah, the thing isn't quite anyway. Yeah. But they did actually change FE mechanics in CS2. But it's like a lot of holes on there. Yeah.
They changed the resistance at the start of the CSGO. Changed the radius of the blast from the grenade. But the way it worked was that it was so hard to see through that people would use that as smoke. So it's really hard to tap.
Well, those are sometimes hard to yeah. That's a good match. Well, I'm like, shit, it's about absolute shocker.
How was your favorite time in CS?
My favorite gun was the it was the AK. The other knives that I got, it's great. just crash and hold and breaks. Just on, you know, on what's it called? Is it Inferno?
Yeah.
I don't know, the one with like, it's called an under, like, just hold that fucking line. Mega. Hold it. And it tends to, just a history of it. It's so good. You don't have to have any skill.
Good Max 7, enjoy it. Max 7. What's the point of doing that?
It's like the Mega, but it would say.
It doesn't work out, I think. Yeah, just less than. I like the $700 terrorist one.
Oh yeah, the Galil. I love this guy.
The ones that open you can't look at. The city.
And the 6 minute purposes.
Yeah, the terrorist. That's not like the. I don't even remember that shit. It's just there. Just back in my mind. It's like you don't need to leave your screen on for too long. It's a burns. It's there. I see the wheel.
You can still tap out your loadout selection. He's mad. That's terrorist. Yeah, it's numbered. Oh, we go to no, that's how we do.
To be fair, on my old mouse, it's very 6 years old, it had 12 buttons inside. I love this. It wasn't though, you'd be surprised. When I was playing some Little Force, I had an macro for every single button, so I could switch to everything like sorry.
Okay.
Or if I didn't type literally, you could change it to WASD on the side.
I can see that being useful for like an amputee, but I don't see the point of it. Or like maybe flames.
Yeah.
You know, those. You don't see, you can't just have the joystick, you need to have like an engine switch.
Yeah.
You need like little screens and so on.
Yeah, so that's around.
You can't leave it on. Oh, and you can be in the sky. You need the ice trap. I was with crack. Every time I ever considered that.
It was terrible. It's a free game.
That's how they get you though.
That's
And
how
then
they
they
get
make
you.
the progression.
£50 for one game.
We don't have to pay money to enjoy that game.
Yeah, it's a nightmare. I did grind like
A decade.
I did the Jets eventually as a very stream.
But you free.
So like,
It's the you play on.
Okay, I'm sorry we're starting a bit late. Now, we looked at the model with government financing yesterday, and I've gone through all of it. So first I'd like to ask if you have any questions on it. Then I will do a little more on it as a review. Okay? Questions? Anything that you want to ask? Do you have a chance to look at the material? Yes? No? Okay. So I'm going to write one here. So the equation to be solved was meaning U1 consumption when young is y minus mu star, and you're solving for mu star. And the factor that we saw comes in affecting consumption when old, because the government is printing money, is 1 over z. This we had worked out yesterday. Of mu star equals U2 with, of course, the same consumption values repeated with. Okay, so this you need to solve in mu star. Now this equation may or may not have a solution. It may have more than one solution. Typically it will have an even number of solutions. Okay? Now, something else that I mentioned, so if you work out total consumption from there, so that is y minus mu star plus 1 over z mu star. So you see that right following. So if you look at what if anything is over after you allocate consumption, the answer is mu star 1 minus 1 over z. I pointed this out yesterday, since what the government consumes at time t was mt 1 minus 1 over z. So that's the increase in the money supply between t minus 1 and t divided by dt. In equilibrium, you will get this as sum g equals mu star 1 minus 1 over z. So what is happening here is, of course, as we started by saying that the government is going to corner resources by printing money. Right? And we solved everything correctly. Because the amount that the government gets to corner is exactly what is left over from consumption. Okay. Endowments less what gets allocated to consumption in the stationary monetary equilibrium is exactly what the government gets to corner. All right? So this part I hadn't worked out yesterday, but we pointed it out. And then I drawn a figure, which I'm going to draw again. Okay. Which is y0. If you're looking at the case where there is no population growth, that point here would be 0. Y, and for the convenience of the way I'm drawing things, I'm going to put the golden rule there. This is in the economy in which basically there's no intervention by the government. And then I said you can draw the offer curve, which I repeat is the combination of all optimizing choices as prices vary. Okay? So you get an offer curve. That looks like that. And I said, consider the case where the government, by choosing an appropriate value of z, is able to corner a certain amount of resources. Let's say the point that we're looking at is that one. So that is y minus g and 0. Okay, where g will be given in equilibrium by that condition. And that will give me another feasibility line, which says, well, the government's taking a certain amount away What's left needs to be allocated in equilibrium. And I see here that I get two intersections with the dotted line. And as I said yesterday, if the government tries to make G too large, my offer curve will stay the same because the consumer's behavior is unaffected, but the second feasibility line will move further towards the origin, and therefore at some point you will not have intersections. And that's the point that we were making there. Okay? Z there is a parameter, and you're solving for mu star as a function of Z. If Z is too large, you will not get a solution. And that's what's captured in the figure here. Is that okay? So you have, in the event that Z is not too large, you have pairs of solutions, as you can see from the figure. You could have more than two, you could have 4 and 6, etc. You have pairs of solutions. And at the solution, you would connect these two white dots, and the slope of the line that you get will be your price line. I'm not drawing it completely. I will draw it that way. And similarly from there, you will get another price line. These will be your equilibrium price ratios, which will reflect the value of Z, as we saw yesterday. Okay, so this one corresponds to the higher inflation rate. Okay, so the government can corner a fixed amount of resources with, in the way I've drawn it, two different inflation rates. One is a low inflation rate, the other one is higher. And then the last point that we made is the allocation Pareto optimal? Okay, now we've not said anything about how the government decides on what the value of G should be, so you have to take that as given. Okay. So given that the government wishes to corner a certain amount, is there a different policy that would do better? And the answer is yes, there is. Okay, look at the problem where you solve for what we call the restricted golden rule, which is to say, you maximize by choosing a value of consumption when young and consumption when old, the utility of C1 and C2, subject to a restriction which is a bit different. The restriction will be C1 plus C2 has to be less than or equal to Y minus G. Once you specify Z, if you have an equilibrium, you will have specific values of mu star. Two values of mu star. Pick any one of them. Okay. You have your restriction that tells you what G is. At equilibrium, G is well defined, and therefore my restricted golden rule problem is well defined. Why is it restricted? Because I'm not allowed to allocate all of Y, because the government is taking away G. So I can solve that problem geometrically, and the algebra of that problem is very similar to what we've already done. Geometrically, what you're going to get is you want to look at the best point on that dotted line, because the dotted line corresponds to that constraint. And then you should be able to convince yourselves that in fact you will get a higher utility at a point like that. That one is your restricted golden rule. So cornering resources by inducing inflation is not such a good idea in terms of efficiency. But of course, it's a good idea in terms of being able to, at some level, you could say, fooling people. This is a rational expectations equilibrium. It's not as though people are making mistakes here. Okay? It's just that they observe inflation in a stationary equilibrium. They may or may not realize it is because of changes in the money supply. But that's what's happening. Is that okay? So in some sense, the important point is that there is an alternative allocation which allows the government to corner exactly the same amount and yet is Pareto superior than your equilibrium. Because over here you would have tangency with the price line, a colored chalk, that's why it's here. Again, you would have a tangency because these are equilibria, and it's clear that this thing needs to be drawn carefully. So I don't want to. You need to draw the figure here carefully with colors if you want to do it. You can check it for yourself. You can show it to me later if you'd like to. But even from that, it's clear that there will be an alternative allocation at which you get high utility. Is it okay? Questions? Anything that you want to ask on any of that? Yeah.
Just can't remember what the Y stands for.
Why is your endowment? In this economy,
Yeah.
you have an endowment when young and zero when old. So why is the total endowment in a period?
All the agents are just one agent.
In this case, there is no population growth. So you can think of it as just one agent at each date. So at any given point in time, there will be a young agent and an old agent.
Why don't we just use the normal endowment?
Sorry?
The normal endowment symbol with the.
Omega.
Yeah.
Because over here you're using something specific, it's just easier to solve and write things down, that's all. You could use omega.
Yeah.
You could use omega if you wish to, okay? Just be careful, because one of the features of the overlapping generations model is, and with many of these things, if your endowment is in both periods, okay, and your endowment is relatively high when you're old, you will have equilibrium, but the interpretation there is equilibrium with negative money. Over here, it's the young agent who consumes less than his endowment and carries the money.
Yeah.
Okay? But if your endowment is weighed heavily towards old age, then in fact it would work the opposite way. The old would be borrowing from the young, so to speak. But you know that is institutionally a difficult one to set up and work out. You really need government intervention there. And therefore, we want to avoid such situations, and the extreme case is y and 0, which is why I use y and 0. Okay? You know, more sort of formal development, one would have spoken about something called the Samuelson case and the classical case. This is the Samuelson case. So it's an extreme example of the Samuelson case, which works really well to explain how money works in these markets. That's the choice. Is it okay? Anything else? All well? Okay, so now what I want to do now is talk about one of the best applications of the overlapping generations model that I'm aware of, anybody's aware of, which went on to change macroeconomics completely. Okay, so this is Robert Lucas's work. And if there was one Nobel Prize that people waited for since the time that paper was written, although when the paper was written, it was turned down by some of the best journals. Get in. Okay? It was published in the Journal of Economic Theory, and it changed macroeconomics completely. The term rational expectation was used in macroeconomics, although Lucas credits some work done on agricultural markets, etc., by Muth. Muth's use of the term was completely different. You don't need to make any notes on these things if you want to. But Lucas used the overlapping generations model, and soon after his work was published, as I said, this was the revolution in macroeconomics. And Lucas was newly given the Nobel Prize in the mid-90s. Lucas expired about 2 years ago, loss for the subject. And just a bit of an anecdote here. Lucas got divorced a few years after having written that paper, and one of the conditions in the divorce agreement with his wife was that if he ever wins the Nobel Prize, she'll get half the money. And of course, she got it. Now, the problem with what I'm going to present is it's a much simplified version, and it conveys the basic idea, but you really won't be able to read Lucas's paper, otherwise I would have asked you to. But if you're interested at the end of the lecture with what you see, you might consider reading Lucas's Nobel Prize lecture, where he talks about what he did and why he thought it was relevant. But one of the points that I would make, I'll make two further points before telling you about what he did. By the way, have you heard about this work at all? Anywhere? You have, right? So, 2 points. One is, unfortunately, I think it's extremely unfortunate, most macroeconomists at that point in time, and even I think now they don't because they have other things to read. At that point in time, most macroeconomists did not have the training in general equilibrium to actually understand what Lucas was doing. Lucas did understand, but most of the people who followed what he was doing, not everyone, but most, did not really understand what he was doing, and so they came up with their own understanding of what he was doing, and that ended up confusing many generations of economists. It's created a complete mess because he introduced new new terminology, etc., which had nothing to do with what Lucas was actually doing. I try to get that across. Okay? I should also say that this material is not on the exam. Don't worry. Sit back and try and learn something without having, putting yourself under any pressure about what do I need to remember. You don't remember anything. So long as you remember that there was an important paper that was written, that's good enough. I understand what is happening, because there is something to learn here. The second is, this was the last piece of work that Lucas, in fact, the only paper in which Lucas used the overlapping generations model. My guess is that he realized that it was a very rich model, and therefore not in the Chicago tradition of being able to produce very clear predictions, which is why he moved away from it. And because he did that, and he moved towards the models that we saw in the first half of the course, so models in which an agent lives forever, the entire profession sort of started ignoring the overlapping generations model. Although research that was done post-Lucas is where the real research on the overlapping generations model was done. What did he move to? He moved to a model in which an agent lives forever. There is just one agent in the economy, because otherwise he couldn't really solve it. And then he came up with this trick of a cash in advance constraint, which he took from Clower and from Gramo Younes, except it was the same person who was buying coconuts in the morning and getting paid for, I don't know, the shell of the coconut in the evening. It was completely artificial. It's very popular in macroeconomics, I also studied it, etc., in great detail. But I sort of have always found that to be not a very sensible way of approaching things, because you get confused by the time you're in. You really get confused, but most models that you look at will leave you asking questions about why it's reasonable. A representative agent cash in advance model sort of throws up that question right at the beginning. And I don't think that's a particularly useful way of proceeding there. Okay? But there's a huge literature, like much of the literature in macroeconomics actually, even today, does the same thing, but with bells and whistles in terms of saying that prices are rigid and this and that. But the basic structure is that of a representative agent, which I don't think is a very good way of doing things. So, with all that said, what is Lucas saying and what does he do? You will remember the work by Phillips, which you would have heard of as the Phillips curve. So, A.W. Phillips, okay, 1958, and Phillips, from what I know, he, around the Second World War, he was, I think, in a British war camp in China, and he spent a lot of time studying Chinese civilization. And then he did economics at the LSE. He was famous for that paper. He was famous for having constructed a contraption which tried to explain how the Keynesian macroeconomy works. And then he gave up everything and became a professor of Chinese history in Australia. Okay, so what is it that Phillips noticed? So Phillips, if you look at the paper, because you can read it, you don't have to worry too much about the equation that he estimates, but the basic idea that he came up with, and there were more details there, but the basic idea was that if you looked at time series data of, I think the UK economy, if I'm not mistaken, it's been a while since I looked at the paper, but if you look at time series data, it appeared as though, so in the data it looks as though, if you are willing to accept, or there is a correlation between higher rates of wage inflation and lower levels of unemployment. Basically that. This is just from the data. Okay? Phillips never said this supports Keynesian macro. He said, as far as I know, he didn't say any of that. He just said this is the data. And based on that, so this is 1958, in the early 60s, Samuelson and Solow, who were involved with advising the Kennedy administration and later the Johnson administration in America, they came up with this idea that, look, this suggests that you can actually reduce unemployment, even long-term unemployment, by accepting higher rates of inflation. So this was the Phillips curve, long-run aggregate supply, aggregate demand, etc., which you must have heard about in some form or the other in your first and second year, possibly even earlier in school, that I don't know. Okay? Now, people seem to forget that in the 50s, there was work both by Friedman and also by Phelps, Well, there was actually the Kagan model earlier, and Friedman Phelps was later. But there was a Kagan model, and Friedman and Phelps, when they saw what Samuelson and Solo were saying, they said, look, this cannot happen over the long run. It cannot be that in the long run you can reduce unemployment forever from some sort of long-run equilibrium. It defeats the purpose of a long-run equilibrium, and simply accept higher inflation. Okay? So a lot of people accepted that. What Lucas wanted to show was something very different. Lucas's objective, and Lucas had an earlier paper with someone called Leonard Rapping. Lucas, something else I should mention about Lucas, I said this about Bewley. Lucas was another person. Lucas's first degree was in history at the University of Chicago. Okay, he did history, and then he decided to do economics. So he taught himself economics over the summer, and he started working towards his graduate work again at Chicago. So Rapping used to do labor economics, and Lucas and Rapping had this paper in the late 60s where they spoke about something similar, but in terms of the labor market. So now what was Lucas's objective? So Lucas wanted to come up with a framework in which the economy was constructed in the way we've constructed all our economies, which is to say, a microeconomics-based economy. No aggregate supply, demand, etc. to start with. Okay? And he wanted to show that, look, in this economy, it will be the case that although there is no trade-off, this is questionable, but this was Lucas's perspective, there really is no Phillips curve that you should observe in this economy. Everybody realizes that money is neutral, etc., so they should not react to expansionary monetary policy. And yet, the data that you would observe that's generated by that economy will show you that the coefficient that Phillips had estimated would be positive or negative, not zero. Is it okay? We are not going to be able to show you all that on the board. What I want to do is to show you how Lucas came up with this economy. So what is that economy that Lucas is talking about? And it's going to bring in aspects that we haven't seen before at all so far. It will be general equilibrium based, it's based on the overlapping generations model, and yet there will be something very different. So the idea is the following. Lucas says, and how he develops this will come in just a moment. He uses something called an islands economy, and the idea of an islands economy goes back to someone called Phelps. Phelps also won the Nobel Prize for other work that he did. They're all very important people. So Lucas said, look, think of the following situation. That the economy, and for the first time I'm going to use the term shocks, but we'll be clear about what we mean by shocks. He says, suppose the economy is hit by two different kinds of shocks. One is a real shock, and the other is a nominal shock. So the real shock is something that could be a state of nature determines the endowment, for example, or preferences. This is the way we've thought about real shock so far. In the Lucas model, it'll work a bit differently, but that's what a real shock. So it affects fundamentals in the economy. The other is a nominal shock, which in this case means the rate at which the money supply changes. Okay, so Lucas says, look, there are both of these shocks. The problem is the agent only observes prices. The agent does not know whether the economy has a high price because it was hit by a bad supply shock, a real shock, or because the central bank decided to increase the money supply. Okay? So at the point at which the agent makes the agent's decision, the agent does not know the nature of the shock. The agent simply observes prices and responds to it. And therefore, you might expect that the agent, as most more or less reasonable humans, would use some sort of a model. We don't write these things down, but that's what we have in the back of our minds, which attributes the possibility of the shock being real as well as nominal, some probability to each. Okay, some probabilistic model. That's how we may take most of our decisions. We might not be working out those probabilities accurately or anything, but our decisions reflect the fact that we attribute positive probability to both outcomes. So based on that, Lucas says, although the shock is nominal, the agent might believe that it's actually partially real, because of which the agent would increase their supply based on the fact that they observe a higher price. in the Lucas model. Okay? And the fact that that is done will show up in equilibrium prices in terms of the time series property that we spoke about. Yet, if agents were to know that the shock is nominal, if they were to know that, then of course they would not respond, because they understand enough of Chicago-style macroeconomics to say that, look, there are no rigidities here. If the shock is nominal, that means it's permanent, so the relative prices will not change between today and tomorrow. And therefore, I should not change my supply. Okay? So if the this signal extraction problem, so that you don't know what is causing the shock, if that were to disappear, then Lucas is saying that you would not observe the Phillips curve in the data. You observe the Phillips curve in the data because that signal extraction problem is there and the agent is responding to that properly. Lucas went further and made claims about what's the best way to conduct monetary policy in such a situation, and those claims are actually questionable. Questionable because he uses a very special notion of optimality where just about everything is bred onto. That's not a good way of doing anything. And there is some work that looked at that more carefully. Unfortunately, as happens with most of these things, the focus has been on what Lucas did, which I think is actually fine, because what he did was quite remarkable. Okay, so what is it that we have here? So let me set up the economy and then various things on that side. I just want to make sure that I've covered everything I wanted to say. Right. So there will be, I won't formally be doing anything in terms of Bayes' rule, etc. But that the way Lucas sets it up is with Bayesian learning, which we won't be able to do here because that would take us too far into new areas. So, endowments. And you have consumption. I'm using the same notation as we have so far, so just put that down. Now, Lucas actually has a slightly different interpretation of the model. The way he does it, because he wants to think in terms of price inflation rather than price and wage inflation, etc. Actually, wage inflation. So he thinks of Y as being a labor input, which can get converted one for one into a consumption good. Okay, so the agent decides how much labor to supply. That's the way to think about it. There's a labor-leisure choice, and beyond that, agents would use that consumption good to decide on how much to consume, etc. But you can frame it exactly in the way we have so far. And he uses a constant returns to scale technology, so it's a one for one. It's a very, very simple way of getting it. Just to observe that it's a bit different than that. So now, as I said, it's an island economy. So there are two islands. And as I said, this idea is due to Ned Phelps. Phelps spoke about island economies in the context of search, etc. And that's before Lucas. Okay? But Lucas took the idea from there. He said there are two islands. And the idea is that when you are born, there's a bunch of identical agents. They all look the same, but it's not one. So when you're born, a fraction of the young people get assigned to island A and the rest to island B. Okay. In Lucas's framework, which is more general than what we will be developing, and for a very good reason, I'll mention that later. In Lucas's framework, there is a probability distribution which says with what fraction you get assigned to each island, right? And there's an IID draw from the probability distribution each period. If I'm using terminology that you're not familiar with, you should ask. Okay? But in our framework, we will make it simpler and we will say there is a given probability with which agents get assigned to one or the other, but we don't know which island is the larger of the two. The key point is that one island will be large, the other will be small. Okay? So two islands for the moment. We don't need any of that detail. I'll come to that in a moment. Two islands A and B. and there will be prices on each island. So PIT is the price on I, which is either A or B. Okay. Let me erase things here. And thinking in terms of what we learned at the beginning of this class, we can write down budget constraints. So when young, it depends upon which island you're on. Of course, you know which island you're. You observe prices on the island. You don't know. You know which island. You know which island you're on. You don't know whether it's a large island or the small island. That's what you don't know. You know the price on that island. So budget constraints. Will be, when you're young, it's PIT, age you're born on T. PIT, so that we carry the agent's identity here, plus whatever money the agent decides to carry over has to be funded from the agent's endowment. And when old, I still haven't told you this, but when old, agents are assigned to the two islands in the following way. You make sure that half the agents from island A move to island B, and half the agents from island B move to island A. This makes sure that the total amount of money on each island is the same. Okay? Right? Any change in the money supply will affect all agents in exactly the same way, because it's an interest payment. Right? So this is a specific rule that we're using for allocating agents across islands when they're old. So depending upon which island you end up on, we need to be careful here, because we need to carry the index of the agent, which indicates the island that they were born on, and then which island they're on when they're old. That is why this is in case they end up on island A when old. Then you're going to get and then there is an interest payment, which is your money supply shock. Okay, which is common across agents and islands. And similarly, PB equals 1, C1A, sorry, C1B, 2 equals 1 equals ME15. This is the nominal shock. Is that okay? So here's an assumption which is actually, if you notice, I had drawn the offer curve earlier and yesterday. I drew the offer curve so that it's everywhere decreasing. That assumption actually says that the substitution effect dominates the income effect. And Lucas makes the same assumption. It's a very reasonable assumption to make when you have a single agent. When you have many agents, then of course you could have bad income effects for some agents, which can lead to perverse behavior of aggregate demand, which Lucas, he didn't want an example which is driven by somewhat extreme assumptions insofar as the microeconomics is concerned. Okay, so the assumption that he makes is, think of it in the following way. When no risk or no uncertainty, okay, not talking about distinction here. If the price ratio increases, okay, so the price of the good when you're young is higher then the standard response, it's not necessarily the only response, but the standard response would be that you would consume less of the good when you're young. Okay? So the assumption is when that happens, it is called growth substitutes. Over here I'm writing it in the form that actually captures what it does. C1t decreases and C2 T plus 1 increases. This is about the only thing that Lucas needs. Okay. And Z T plus 1 is random. We actually have it independently and identically distributed across time. And the value is made public end of the period. So after all change has taken place, that's when the value is made. And as I said earlier, yes,
The agents know roughly well, like how long T plus 1 could be.
they know the distribution.
They know the distribution.
Yes.
Okay, sorry.
Yes, it's fully Bayesian. And this is why, as I said, I can't ask you to go and read the paper because it becomes messy to deal with these things. And there's an area called dynamic programming that Lucas uses extensively, which you don't know about. Okay? Otherwise, I would go to read the paper. It's a very difficult paper to read. Make that clear. It's not trivial, far from trivial. Okay. I don't know how much we'll be able to cover, but let's. So that's one novel element that you have uncertainty in that form. Okay, and just to take an example here, this is not what Lucas does, as I said, but 2/3 of the agents are assigned to one of the islands. And the rest to the other. Okay. Choice of which is larger is random. And this is the real shock. So one of the markets will be large, the other small. In Lucas's original model, the probability with which so even the size of the island is random. That's the way to put it. Okay, it's not that it's 2/3 always. Here, to keep it simple, we're saying it's just 2/3 and 1/3. You don't know which one is larger. But in Lucas's original model, you actually have the size is itself a random variable. And you need that because in the model that we're looking at, the special case, other than some very specific numbers, the Lucas problem disappears for technical reasons. So the Lucas problem actually requires Lucas specific. It's not as if he didn't realize this. And I don't know how well aware he was of these things, because this relates to an area called general equilibrium with asymmetric information, and that was just developing at that time. Very little was known about these things at the time at which Lucas was doing his work. The first papers are from the late 60s by someone called Roy Radner, and then some other work by Jerry Green around that time. But the real stuff in that area got published in the late 70s. So after Lucas. Now, look at the case where there is no nominal shock. Just to understand what is happening. Suppose Z equals Z. Okay, so there is no nominal shock here. So the market clearing condition. Let me erase that. Let's write this. So what's the equilibrium condition? So it's the number of people on island I, equilibrium on I. So everything can be captured with just the money market as we've always done in our overlapping generations framework, because it's just one good. So the number of people on island I times the amount of money that they demand, given that they are born on island I. What they don't know is which is the larger island, right? But they know what the price is on that island. Depends on the price that they face when they're young, as well as prices that they expect to face when they're old. Expect to face in the sense of these are, in Lucas's framework, these are, of course, distributions. But over here, if you're thinking of these as point price expectations, which are correct, there's no problem with any of that. And by our rule, in the way old agents are assigned, we said old agents assigned so that the total amount of money on each island is the same. So that's the market clearing condition. Okay? And therefore, from our budget constraint, you can rewrite that as EIT, so use that one. Hopefully, you will see it's not a problem. Equals MT and 2 and NIT. And then you look at the net trade. So the amount of money from there is equal to the price times Y minus C, right? Except that I'm going to write out what C depends on. So C, as we said, is Y1T, which again depends on all three prices. Using the budget constraints, I'm not writing that. Now, by our assumption, if the price on island A is less than or equal to the price on island B, okay, it's the same assumption. So if the price on island A is less than the price on island B, then the consumption of the agent who's young and born on island A, I'm not writing everything out, could be at least as large as the consumption of the agent who's born on island B, given that the prices that they face when old are the same. That's important. You're moving just one price. You're moving the price that they face when young. Is that okay? That consumption will be greater. And now we put these things together. Okay? So suppose, this is by contradiction. Suppose A is smaller. Okay? So NA is less than NB. And the price on A is lower. Suppose that is the case. So if the price on A is lower, you see from here that consumption when young on A will be higher. So Y minus consumption on A will be lower. So this term will be lower on island A. The population on island A is also lower. So the price should be higher. Okay? This is from market clearing. So market, please be, this is about the only thing that there is to understand what I am doing of Lucas's model. If you say that the smaller island has the lower price, you run into a contradiction, because from market clearing and budget constraints, etc., the smaller island will have the higher price. Okay, so in other words, the only thing that you can assume is not this, but in fact, this should imply that the smaller island will in fact have the higher price in equilibrium. If there is scarcity, the price should be higher. So Lucas is not saying anything strange. Okay, so if there is scarcity, the price should be higher, and therefore, if you were a smart agent, you don't need to know which island you're on. You can see it from the price. The price will reveal that information to you. This was Lucas's innovation. Understanding that prices carry information. Many economists, you go back to Austrian school, all sorts of people have spoken about these things. But to write it down and work it out is it's a completely different ballgame. It's completely non-trivial. Okay? Economists have always thought of prices as defining budget constraints and then market clearing. Lucas is saying prices give you information. Okay? So if there is no guarding, if there is no nominal shock that interferes with the quality of the information, then by looking at the price you would know exactly which island you were on. But of course, the central bank intervenes. And when the central bank intervenes, it reduces the quality of that information. But agents will react optimally to that. So agents have set up a model. This is where Lucas takes it to the extreme. He says, well, they understand how the economy works. So when they see, what they actually see is an equilibrium price function. They realize that depending on the state of nature, which is both the size of the island and what the central bank is doing, there will be a certain price. They understand exactly what that relationship is. But what they see is just a price. Based on that price, they infer information using Bayes' rule to figure out what are the probabilities, respond accordingly, and the equilibrium captures all of that correctly. Non-trivial, completely non-trivial. Okay, but that is what he did. And he showed that if you do that, you work out the equilibrium and look at the derivative of the price function, you get a non-trivial slope coefficient in terms of the probability limit, which is what an econometrician would estimate. That's what he did. And then, as I said, he claims that a K% money supply rule is the best thing that you can do there. The answer is yes, given his very strange, very weak notion of optimality, where anything else would also be optimal. You don't need to worry. It doesn't pick up the K% rule as such. It's just that the K% rule satisfies that property. Okay? And an appropriately designed random